Okay, great, thank you. Okay, so well, Martin already introduced me in the paper I will present. Just before starting, I will just say I will only highlight the most important things, of course, as this is a very short presentation, but don't hesitate to come to the poster afterwards. We can talk more elaborately. So I will just keep it short. We have developed an application well, for a specific case study. This is for the selection of assets for an investment profile. Now, to do this, we use two kinds of rules. Basically, there's some eligibility criteria on the level of the asset itself, but then there's also selection criteria on the level of the portfolio. So, for example, maximum 10% of shares can come from the same industry, for example. Now, we have, so the previous process that used this was that clients could give in a profile in natural language, and then an operator at the company would interpret it and so translate it, send it back to the client for validation, after which it would be programmed and automatic asset selection would happen. Now, of course, before the interpretation of the operator was correct and it could be validated by the client, this typically took a number of runs, and the process could take easily 3 months or even more. So, of course, this is a process with a lot of operational risk, which is also time consuming. So therefore, we looked for an application that could automate this process, in which the clients could immediately describe their profile in natural language, and which would be translated automatically and would go to an automated asset selection immediately. Now, the creation of this application actually involved two main research challenges. The first one is how can clients enter this profile, which is in natural language for them, but is computer readable for the selection of the assets, of course. And the second part is if we have this client profile that is computer readable, how can we use it to give some more services to the client that goes beyond the simple selection of assets. So we have developed an application that consists of two parts. First, it has a natural language interface, which I will discuss right now. And then underlying, there's a knowledge-based system that uses logic to reason with it to actually select the appropriate assets. So the natural language interface, basically it's an interface and clients can enter their profile in two ways. The first way is by using the building blocks as you see on the screen right now. So this gives, as a result, a sentence that is highly structured because it is built with those blocks, of course. But there's also a possibility for clients to enter a natural language sentence. You see this here. What the system will do then is try to interpret it and give three possible interpretations with each like a likelihood of how correct it is. The client can then select one sentence and then it appears here with the building blocks as before, and the client can still make some amendments before validating it. So in these two ways, the client can build a profile that consists of several sentences. Underlying, this works with a neural network and a tuple tree. And a tuple tree actually reflects the way that concepts are linked to each other and how which blocks will be shown to the client, in fact. So when the profile is completed, it is entered into the knowledge-based system. Now, I'll first give a short explanation on what is a knowledge-based system. Basically, it's a system that consists of a knowledge base that contains only relevant domain information, and it's separate from the inference tasks that use it to actually reason with the information and give a final solution. The knowledge base it consists of three parts. It consists of the vocabulary, which is actually the ontology of the domain, so which concepts are used in the domain. The theory T that contains the sentences that were created by the client, and it can also contain have a structure that assigns certain values to the vocabulary or to a part of the vocabulary. Now, the language that we use to construct our knowledge base is FO. This is a language that is based on first-order logic, but that expands it with aggregates, types, arithmetic, and definitions. Now, in our application, we specifically use definitions a lot. So then the knowledge base is one part, the inference tasks that are used are the other part. And well, some examples of that are model expansion, deduction, or optimization. I told you before that we use a lot of definitions in the knowledge base, and basically the eligibility of an asset is translated into two definitions. One definition for not eligible. So clients can also say, okay, I don't want this kind of assets. And one definition for assets that are eligible. Now, in the financial sector, caution is very important. So the non-eligibility takes precedence over the eligibility. And you can see that by the not eligible definition that is here also included in the definition of an eligible asset. So an eligible asset can only be eligible if certain conditions are met and if it's not eligible. So this brings us to the inference tasks. That's the second part of the knowledge-based system. One of the most important inference tasks is model expansion. So if we have a certain theory T which contains the investment profile, and we have a partial interpretation IP that contains some values for some of the concepts of the vocabulary V. The model expansion is going to compute a complete interpretation IT. So an interpretation that assigns a value to all the concepts of the vocabulary V, such that it expands IP and that it satisfies all the rules in T. We have used this in our application to check if two profiles are equal. Another important inference task is propagation. So given a certain theory and a partial interpretation, propagation is going to calculate all the results that hold in all the model expansions of IP. Now, in practice in the application, this means that once you start entering sentences, you will get an overview of all your assets, and then if it's eligible, it turns green. If it's non-eligible, it turns red. And the more sentences you add, the more assets will get a color, of course. There's much more inference tasks that we have used in our application. We have also combined inference tasks to give more or to create more services, but that's something we can discuss in a poster session. Now, I think what I would like to mention is that so the prototype that we have created was very successful. So currently it has been developed and is under commercial implementation. We have, of course, tested it so to make sure that the eligibility criteria of the client actually resulted in the correct profile. We've used profiles of up to 20 rules that we applied on portfolios of about 300 assets, and it gave an answer whether certain security is eligible or not within 3 seconds, so which is good for business use. And we've also compared this with the translation in the previous system, and well, our profiles of 20 rules correspond to more or less 3,000 if then else statements in the legacy system. So from this results that indeed this results in a strong reduction of the operational risk. Moreover, because we can combine inference tasks, we are able to offer additional services to the clients. So to conclude, the application combines a powerful combination of AI techniques, a neural network with the natural processing module on one hand, and state-of-the-art knowledge-based system to calculate the eligibility of profiles on the other hand. So thank you for your attention, and I warmly welcome you to talk to me in the poster session.